Well, hello to you, and hello to section 5.2. I have just a few quick notes out of this section that is dealing with polynomials. The section 5.1 was dealing with monomials, where there was one term. Terms are separated by addition and subtraction. So when we talk about polynomials, that means we have more than one monomial. So for example, you might have 3x squared plus 5x minus 4. That would be a polynomial. And specifically, it would be a trinomial because there's three terms separated by this addition and that subtraction sign. So in this section, we're going to deal with polynomials, and we're going to talk about adding and subtracting them and how to multiply them. So one of the things first we need to make sure we're clear on is what's called the degree of a polynomial. The degree of polynomial is just has to do with the power that the variable is raised to. So x to the first power, that would be a first degree monomial in this case. This would be a second degree monomial or a third. In a problem like this, where you have lots of terms, the degree of the polynomial is the degree of the highest monomial. So since 4 is the highest power on the variable, that would be the degree of that polynomial. Even if this 4 down here at the end was maybe raised to the 8th power, since that's not a variable, the 8 doesn't matter in that case. Now, it would still change the value of 4, 4 to the 8th power, whatever that number is, but the degree of this polynomial is based on the degree of the highest power on the variables. So, not a variable, don't worry about the 8. If you have a term where there's more than one variable in that term, so I have 3 times x squared times y to the third times z, now the degree of that polynomial, or in this case it's a monomial because it's just one term, it's the sum of the variables on the exponents. So here's a 2, there's a 3, that's 5, but on the z, even though it's not written, there's a 1. So 2 plus 3 is 5 plus 1 is 6. The 3 has a 1 on it as well. We don't write that. It's 3 to the first power. But because that's not a variable, we don't worry about it. So the degree of this polynomial would be 6. And again, it's a monomial. So one of the things we have to be able to do is to add and subtract polynomials. Well, one of the things that you should remember back from Algebra 1 days is you can only add and subtract like terms. And what makes something like terms is that they have the exact same variable part to them. So let me back up for a second. So if I have 3x squared, it can only add to something that has an x squared in it. So 3x squared, and make up something, let's say I have 4x squared, 7x squared. Now when you add and subtract, notice that the variable doesn't change. What you're saying is I have 3 of something, and then 4 more of the same thing, so altogether I've got 7 of those things. When you add and subtract, the name doesn't change. Just like if I had 3 apples plus 4 apples, I end up with 7 apples. I don't get apples squared, I just get apples. So, same thing with variables. When you add and subtract, the name, and that's the variable part, doesn't change. So let's do this problem. It's a subtraction problem, and I'm going to take this polynomial and then subtract this polynomial. So one of the first things to do is to kind of get rid of the parentheses here and understand out here there's a 1, even though you don't usually write that 1, but I could think about distributing the 1, and that's how I get these parentheses to disappear. So I would get 3x squared minus 2x plus 3. Of course, I get just exactly what's in the parentheses. But what happens here is understand that there's a negative 1 that's being distributed to everything. And that's the thing that a lot of people mess up. They don't distribute it to everybody. So it would be negative x squared, and then this positive 4x would become negative 4x, and then the minus 2 would become plus 2. Now what I want to do is try to go back and find some like terms if possible. So 3x squared and the x squared can go together, and that's going to get me, well, 3 minus 1 is 2x squared. And then the 2x and the 4x can go together, and that's going to get you minus 2 minus 4 minus 6x. Again, the variable doesn't change. And then the numbers can go together, and the 3 and the 2, and that gets me positive 3 plus 2. That gets you plus 5. And so that's the sum, or sorry, in this case, difference of those two polynomials, adding like terms. Also in this section has to do with multiplying. So let's do a little multiplication, see what I get here. In this problem, the 2x is on the outside, and I can think of 2x as one thing. So I'm taking this 2x times everything that's inside. So the 2x is going to go to this one, the 2x is going to go to that one, and the 2x is going to go to the 5. So when I multiply first ones, 2x times 7x squared, well, 2 and 7, well, now let me write this out. So I've got 2x and I'm multiplying times 7x squared. But you can think of that as 2 times x times 7 times x squared. And I could think of that as 2 times 7 times x squared. Now, there's no way or reason in the world that you need to write that out, but in your head, understand that when you do that, 2 times 7 then is 14, x times x squared is x to the third power, because when you multiply numbers that have the same base, you add their exponents. I can just do that right here. Just understand that the variables end up multiplying and the coefficients end up multiplying. So this first multiplication would give me 14x to the third. And when I distribute to the next one, it's going to be negative. So 2 times 3 is 6. X times x is x squared. And then 2x times the 5 gets me plus 10x. And there you go. That would be the product of those two things. Let's do one more that's a little more complicated. Back here, I was taking a monomial and distributing it. Now I'm going to take a binomial, and actually this is a trinomial times a binomial. And let's do this distributive property. Now what happens, and I see I made a mistake when I copied the problem, so let me fix that. This should be an x right here, because everybody else is x's. So when I do this multiplication now, I'm going to take and distribute this x squared to both of those terms in there. So the x squared times the x is going to be x to the third. And then x squared times the 4 would be plus 4x squared. Now I'm going to distribute the 6. 6 times x is plus 6x squared. And then 6 times 4 is plus 24x. And then the negative 2 times x is negative 2x. And the negative 2 times 4 is minus 8. And so now, let's go back through and put some like terms together. Let me change the color here, get something different. And so then nothing adds with the x cubed, so I just have x cubed. But these are like terms because they have the same variable, so plus 10x squared. And again, when you add and subtract, nothing happens with the variable part. You're just adding how many of them you have. So I got 4x squareds plus 6 more x squareds, well that's a total of 10x squareds. And then 24 minus 2 is plus 22x and minus 8. Now notice something the way I've written this. The powers go x to the third, x to the second, x to the first, and then x to the 0, because x to the 0 is equal to 1. So you could think of this as x to the 0. There's really no reason to, though. But it's that term's degree is 0. And what I've done is written this in what's called descending order, just simply by the powers, the largest power to the smallest power. And almost always you will write a polynomial in descending order. Well, that's the information out of 5.2. I hope that helps you and gets you a good start on what's going on. As always, if you got any questions, just let me know.